Now this question takes a little bit of reasoning through, and one of those questions you have to just read carefully, and you should be able to apply chemical principles you know and work it out. Now we're talking about magnesium chloride and silver chloride, and when we look at these we can find out certain bits of information. The melting point obviously for magnesium chloride is much higher, its lateral enthalpy is much greater, and that would indicate that the bonds between the magnesium and chloride ions in the lattice are much stronger if it takes more energy to break these. And then we look at the enthalpy of hydration, which is energy change when 1 mole of gaseous ions is hydrated, and we notice that the energy released for this for magnesium is much greater than it is for the silver ion. Obviously the chloride ions are common to both silver chloride and magnesium chloride. We're asked to explain why it's possible for some ionic solids to dissolve in water in spite of the fact that there's strong ion forces of attraction. So for magnesium chloride it's got these very strong bonds, and yet it dissolves easier in water than silver chloride. Can we explain this? Well, one of the things first of all to realize is when we look at the information given, we're given lattice enthalpy, we're given melting points, and we're given the enthalpy of hydration here. Now, but we aren't actually given any information on the enthalpy of solution, which is the enthalpy change when 1 mole of gaseous ions, when 1 mole of solid dissolves to form a solution. Now this sounds like we're going from this, the solid, to the ions here. So using these two bits of information, before we even get into discussing this, we could actually work out the data for the enthalpy of solution for silver chloride and magnesium chloride. And that's what we'll do first. Now if we do these calculations, and remember what we're trying to calculate, because that's important in working out how to do it, is the enthalpy change when we go from a solid to solution. So this is the enthalpy silver chloride has as a solid, and this is the enthalpy that happens when it is hydrated. We've done that by just adding minus 475 and minus 361, and if we add those two together we get a result that there's a 80 kilojoules per mole difference. Now if we do the same for magnesium chloride, going from a solid to where it becomes hydrated, it has this much enthalpy at the start. This is the enthalpy change that occurs when it gets hydrated. If we add those two together we get a net difference of minus 13 kilojoules per mole. So one of these is endothermic and one of these is exothermic. Well, what does that tell us? Well, for a start we know that the bonds in silver chloride are weaker. The melting point and the lattice enthalpy tell us that, and the amount of energy given off when it actually dissolves is also less. So, and the fact that it's endothermic means that this process is less likely to proceed. It's not going to happen now, or it will happen but just to a moderate degree. Now magnesium chloride, we know it's got stronger bonds because of its melting point and because of its enthalpy, lattice enthalpy, and when that is dissolved in water, this is an exothermic reaction, so we know in forming bonds in water a lot more energy is released than it actually takes to break these bonds. This is more likely to proceed, it's going to be more stable, and it's going to result in a much stronger bond or more stable bond between the ions and the water, those kind of interactions through hydrogen bonding, etc. So from this we can see that if more energy is actually released in the process of dissolving than it takes to do it, it's more likely to happen. Okay, and that's that question really answered. Now just remembering in these questions that it's important to talk about all points. You should be talking about lattice enthalpy, what that means, the melting point, what it means in terms of strength of bonds, and also in doing this calculation what that indicates as well. Okay.